Kylo Limit Loren, talking to you about vertical asymptotes and infinite limits. What is a Jedi's favorite temperature? Lukewarm!
The first vocabulary term is a vertical asymptote. That's the line x equals c toward which a function f of x approaches infinitesimally closely as x approaches c, but never reaches the line as f of x increases or decreases without bound. So here we have a line x equals c. This is our x value, we'll call it c, toward which a function f of x approaches infinitesimally closely, gets super close to the line, but never quite gets to that line x is equal to c. That would mean that the line x equals c is a vertical asymptote of the function f of x. The next vocabulary term is an infinite limit. That's when the limit of a function equals infinity or negative infinity, where the function grows without bound as it approaches some value c. So here we have our x value c, and as our function approaches the value x is equal to c from the left, you can see that our y values go towards negative infinity. Therefore, the limit as x approaches c from the left of our function is equal to negative infinity. Now, as our function approaches the x value of c from the right, our y values go toward positive infinity. Therefore, the limit as x approaches c from the right of our function is equal to positive infinity. So let's talk about this vertical asymptotes theorem. It says, let h and g be continuous on an open interval containing c. If h of c is not equal to 0 and g of c equals 0, and there exists an open interval containing c such that g of x cannot equal 0 for all x not equal to c in the interval, then the graph of the function f of x is equal to h of x over g of x has a vertical asymptote at x is equal to c. So this is just a very confusing way of saying if there is some x value where you plug it into the function in our denominator of our rational function, and that x value causes this function in the denominator to equal 0, then your function will have a vertical asymptote at x is equal to c. And remember, if you have a function where you plug in the value of c to the denominator and numerator and both turn into 0, then that's going to be an indeterminate form. But if this is a number and this is 0, you will have a vertical asymptote at whatever x value c that you plugged in for that particular function. Okay, properties of infinite limits. This says let c and l be real numbers and let f and g be functions such that the limit as x approaches c of f of x equals infinity and the limit as x approaches c of g of x equals some number l. So the first property, the sum or difference property, says the limit as x approaches c of f of x plus or minus g of x would have to equal infinity. And this makes sense, right? The limit as x approaches c of f of x is infinity. The limit as x approaches c of g of x is a number. So infinity plus or minus a number is still going to be infinity. Next, we have the product property. This says the limit as x approaches c of f of x times g of x is equal to infinity, so long as L is greater than 0. And this again makes sense. If you evaluate each of these limits separately, you end up getting the limit as x approaches c of f of x, which is infinity, times the limit as x approaches c of g of x, which is a positive number L, and infinity times a positive number is just infinity. If you were to change this to a negative number, it would just change this to negative infinity, right? Infinity times a negative number would be negative infinity. Now the quotient property says the limit as x approaches c of g of x over f of x has to equal 0. And this again makes sense. If you evaluate each of these limits separately, you end up getting the limit as x approaches c of g of x, which is a number, over the limit as x approaches c of f of x, infinity. And any time you're evaluating a limit and you have a number over infinity, that would equal 0. This says similar properties hold for one-sided limits and for functions for which the limit of f of x as x approaches c is negative infinity. We talked about that earlier.
Power! Unlimited power! From example time!
Now example 1 says determine whether f of x approaches infinity or negative infinity as x approaches c from the right and left. So here our c value is -1, and you can see we have an asymptote here. So the limit of our function as x approaches -1 from the left, you can see is going to be negative infinity because our function goes towards negative infinity. The limit of our function as x approaches -1 from the right is going to be positive infinity because our function keeps increasing exponentially as it approaches -1 from the right. Here our c value is +1. So again, we start from the left. We have the limit as x approaches +1 from the left. You can see our function goes towards positive infinity. So the limit as x approaches 1 from the left of f of x is going to be positive infinity. However, as our function approaches 1 from the right, you can see it goes towards negative infinity. So the limit as x approaches 1 from the right of our function is equal to negative infinity.
Ray is stupid and I hate her and I didn't even want her to be on my side anyway. You try.
Okay, here we're doing the same thing. So we look the limit as x approaches -2 from the left. You can see our function goes towards positive infinity. Therefore, the limit as x approaches -2 from the left of f of x has to equal positive infinity. As we come in from the right, our function again goes towards positive infinity. Therefore, the limit as x approaches -2 from the right of f of x also equals positive infinity. Over here, we're looking at a c value of pi over 2. So we look pi over 2, our x value is right here. As our function comes in from the left, it goes towards positive infinity. So the limit as x approaches pi over 2 from the left is going to be positive infinity. And the limit as x approaches pi over 2 from the right goes towards negative infinity. So that's going to equal negative infinity. Okay, example 2 says find the vertical asymptotes, if any, of the graph of the function. So if you recall from algebra 1 or algebra 2, a vertical asymptote is going to be any x value that would cause the denominator equal 0. But first you have to check, does anything cancel out? Are there any terms or quantities that cancel out in the numerator and denominator? Because those would create wholes rather than asymptotes. So here nothing cancels out. So all we have to do to figure out what x values cause the denominator equal 0 is set the denominator equal to 0 and solve for x. So I do that, and in order to solve for x, I square root both sides. I get x minus 3 is equal to 0. Add 3 to both sides, I get x is equal to 3. That means that 3, if I were to plug it in for x, would cause the denominator to equal 0, and therefore create a vertical asymptote at x is equal to 3. We confirm this with our graphing calculator, and you can see that at x is equal to 3, we have a vertical asymptote. For part B, we're doing the same thing, except we want to check again, is there anything that cancels in the numerator and denominator? Well, the denominator would factor into s minus 5 times s plus 5, but that doesn't cancel out with the numerator, so we're good. We just take our denominator, set it equal to 0, and solve for s this time. If we set it equal to 0, again, there's two ways to solve this. One would be to factor this, and you get s minus 5 times s plus 5, set both of those equal to 0 and solve. Or you could just solve this right away, add 25 to both sides, and square root both sides, you get s is equal to plus or minus 5. That means both positive 5 and negative 5 would cause our denominator equal 0, and therefore create a vertical asymptote at s is equal to 5 and s is equal to negative 5. We look at our graphing calculator, and you can see that at s is equal to negative 5 and s is equal to positive 5, we have vertical asymptotes.
You try.
Okay, again, first we want to check, is there anything that cancels in the numerator and denominator? Nope. So then we just set our denominator equal to 0 and solve for x. So if I set our denominator equals 0, here I add 1 to both sides to solve for x, and now I have e to the x equals 1. I have my variable in the exponent. Now we think back to algebra 2, how did I get the variable out of the exponent? I actually, in this case, have to take the natural log of both sides. The natural log of e, those cancel out, and I'm just left with my exponent, which is x. Over here, ln of 1 is going to be 0, so I get x is equal to 0. This value would cause our denominator to equal 0, and therefore create a vertical asymptote at x is equal to 0. I confirm this with my graphing calculator, and you can see that at x is equal to 0, we have a vertical asymptote. For part B, I again am trying to figure out where the vertical asymptotes are. And before I do that, I want to figure out, is there anything that cancels in the numerator and denominator to create a whole rather than an asymptote? So first, I factor out a 4 from the numerator, and I get 4 times the quantity s minus 2. In the denominator, I factor out an s, and I get s times the quantity s minus 2. You can see that the s minus 2's then cancel out and leave me with the function 4 over s. So there is going to be a whole at s is equal to 2. But where's my vertical asymptote? I take the denominator, set it equal to 0, and then solve for s. Well, it's already solved. I know that there is going to be a vertical asymptote at s is equal to 0. So I look at my function to confirm it on my graphing calculator, and I see that at s is equal to 0, or x is equal to 0, I have a vertical asymptote. Example 3, we're doing the same thing, except this time we have trig. Now, secant of pi x. It doesn't look like it's a rational function, but it is, right? It's 1 over cosine of pi x. So we need to figure out what values of x would cause this to equal 0. Now, since pi is already here, the values of x that we would plug in to cause cosine to equal 0 would be 1/2. Negative 1/2, 3/2, negative 3/2. Those, if you were to multiply them by pi and then take the cosine of them, would be equal to 0. Now, make a formula using n for the integers. Because it's an infinite amount of vertical asymptotes for secant, I need to figure out, how do I determine all of the x values for which this particular function has a vertical asymptote? Well, you see that the numerator is always going to be an odd number, and the denominator is always going to be 2. So in order to do this, all I have to do is write x has to equal an odd number, 2n plus 1, over 2. And again, n is an integer, so it can be positive or negative. So this is a formula for all of the vertical asymptotes for this particular function. And you confirm this with your graphic calculator, and you can see that there are actually an infinite amount of vertical asymptotes for this function. For part B, we have cotangent of x. And again, this doesn't look like it's a rational function, but it is. It's cosine of x over sine x. Now again, we need to figure out what values of x would make the denominator equal 0. So what values cause sine to equal 0? That would be negative pi, 0, pi, 2 pi, and so on. So we need to make a formula for all of those x values to make our sine value 0. Now what causes sine to equal 0? It's negative pi, 0, pi, 2 pi. So it would be any integer times pi. So x equals n pi. For every x equals n pi, there's going to be a vertical asymptote for cotangent of x. Now you can see, we confirm this with our graphic calculator, at every n pi, we have a vertical asymptote for cotangent of x. Now example 4 says determine whether f of x approaches infinity or negative infinity as x approaches c from the left and from the right by completing the table. So these are pretty easy. We've done this before. We have 3 x values to the left of our c value 1 and 3 x values to the right of our c value 1. We're going to plug these in for x in our function and get the y values that go with them and then determine our limits. So we plug in 0.9 for x here and here, get the y value that goes with that. Plug in 0.99 for our x here and here, get the y value that goes with that. Plug in 0.999 for our x here and here and get the y value that goes with that. Same thing on the other side, plug in 1.1 for x, plug in 1.01 for x, and plug in 1.001 for x, and you get the y values associated with those x values. Now all you have to do is look at the y values as you approach 1 from the left and from the right. So our limit as x approaches 1 from the left looks as though we are approaching negative infinity. We go from negative 19 to negative 199 to negative 1,999. So the limit as x approaches 1 from the left of f of x has to equal negative infinity. As we come in from the right, we see that we get exponentially greater y values. Therefore, the limit as x approaches 1 from the right of f of x has to equal positive infinity. We confirm this with our graphing calculator. You can see that as x approaches 1 from the left, our f of x goes towards negative infinity. As x approaches 1 from the right, our f of x goes towards positive infinity. Okay, so we're doing the same thing here. I have 3 x values to the left of our c value negative 4 and 3 x values to the right of our c value negative 4. We want to plug each of these in for x to our function and get the y values that go with them. Now, once we do and we plug in all those and get the y values associated with our x values, we look at what the x values are trending towards as we approach our limit, x is equal to negative 4. Now, from the left, the limit as x approaches negative 4 looks like our function is increasing exponentially. Therefore, we can say the limit as x approaches negative 4 from the left is going to equal positive infinity. The limit as x approaches negative 4 from the right, however, our y values are decreasing exponentially. So we would say the limit as x approaches negative 4 from the right would be equal to negative infinity. Confirm this with our graphic calculator. You can see x is equal to negative 4 is right here. As we approach negative 4 from the left, our f of x goes towards positive infinity. As we approach negative 4 from the right, our f of x approaches negative infinity. Now example 5 says find the one-sided limit if it exists. So anytime you're given a limit, one-sided or otherwise, evaluate it by taking that c value and plugging it in. So I'm going to plug in 2 for x, simplify, I end up getting negative 1 over 0. Because I have a number over 0, that means this is undefined, and we are going to get a vertical asymptote at x is equal to 2. So since we know it's a vertical asymptote, all we have to figure out now is as our function approaches 2 from the left, are we going to approach a y value of positive infinity or negative infinity? So in order to figure that out, we create a table. We pick 3 x values less than 2, 3 x values greater than 2. But in this case, since we're approaching from the left, we only need the 3 x values that are less than 2. So we can cross these guys out over here. We take 1.9, plug it in our function, and get the y value that goes with that. Take 1.99, plug it in for x in our function, get the y value that goes with that, and take 1.999, plug it in for x in our function, and get the y value that goes with that. And you can see, as we get closer and closer to 2 from the left, our y values get more and more and more negative, exponentially more negative. Therefore, the limit as x approaches 2 from the left of our given function has to equal negative infinity. We confirm this with our graphing calculator, and you can see at x is equal to positive 2, we have a vertical asymptote, and as we approach 2 from the left, our function goes towards negative infinity.
Anakin was not the chosen one. I was. You tried.
Okay, so we're doing the same thing. Anytime you have a limit, one-sided or otherwise, you want to plug in your c value for x and evaluate it to see if you get an answer. Well, here you can make life a little easier on yourself and see that this is a quadratic trinomial down here that factors into x minus 2 times x plus 4, and the x minus 2's cancel out, meaning there's going to be a hole at x equals 2, but you're not worried about that because you're taking the limit as x approaches negative 4. So we cancel those out. Simplify, we get the limit as x approaches negative 4 from the right of 1 over x plus 4. We now evaluate this by plugging in negative 4, and we get 1 over 0, meaning that there's going to be a vertical asymptote at x is equal to negative 4. We then create a table, picking 3 x values that are less than negative 4 and 3 x values that are greater than negative 4. But we want to figure out the limit as x approaches negative 4 from the right. So we want numbers that are greater than negative 4, so we're not worried about these guys over here. We know, because there's a vertical asymptote, that the limit as x approaches negative 4 from the right is either going to approach positive infinity or negative infinity. So we plug in these 3 x values to our given function here or here. This would probably be a little easier. And figure out the y values that go with those to see whether or not we're approaching positive or negative infinity. And you can see that our y values are increasing exponentially, meaning that our function approaches positive infinity as x approaches negative 4 from the right. Confirm this with your graphing calculator. You can see at x is equal to negative 4, as our function approaches negative 4 from the right, our y values approach positive infinity. Example 6 is find the one-sided limit if it exists. So again, we evaluate, we plug in 0 for x and see if we get an answer. Clearly, we have something that is undefined, meaning that we have a vertical asymptote at x is equal to 0. We then create our table, making 3 x values to the left or less than 0 and 3 x values to the right or greater than 0. And which ones do we need? Well, we are coming in from the left, so we need the x values that are less than 0, so we don't need these guys over here. We are now going to plug these in for x to our given function and get the y values that go with those. We see that we are approaching negative infinity as x approaches 0 from the left, so we can say that the limit as x approaches 0 from the left of our given function is equal to negative infinity. We confirm this with our graphing calculator, and you can see at x is equal to 0, our function is approaching negative infinity from the left.
Do or do not. There is no try. Except for this, you try.
Here, again, we have the limit as x approaches negative 3 now. We evaluate that by plugging it in. We end up getting 9 plus 1 over 0. We again have 0 in the denominator, meaning that there's going to be a vertical asymptote at x is equal to negative 3. So the limit as x approaches negative 3 from the right is either going to be equal to positive infinity or negative infinity. So to figure that out, we create our table, pick 3 x values to the left or less than negative 3 and 3 x values to the right or greater than negative 3. Which ones do we need? We need the ones to the right, so we don't even need these guys. Once you get better at this, you don't have to create both sides. You can just determine which side you need and create that side only. We now take negative 2.9, plug it in for x in our given function here and here, and get the y value that goes with that. Same thing for negative 2.99 and negative 2.999. You can see that our y values are increasing exponentially, meaning that the limit as x approaches negative 3 from the right of our function is going to equal positive infinity. And confirm this with your graphing calculator. You can see that as our function approaches negative 3 from the right, it goes towards positive infinity. Now example 7, we're going to do a little trig. So here it says the limit as x approaches negative 1 from the right. Anytime you have a limit, you evaluate it by plugging it in first. So we plug in our c value for x here and here. And what we do is when we plug those in, we now need to simplify this. So this is going to be negative 1/2 over here. You may not know what tan of negative pi over 2 is right off the bat. So if you wanted to simplify this a little further, you could see that we're actually going to get a number in the numerator and 0 in the denominator. Because of that, we know we are going to get a vertical asymptote at x is equal to negative 1, because that caused our denominator to equal 0. Now all we have to determine is, as we approach negative 1 from the right, are we going to go towards positive infinity or negative infinity? So to do that, we create our table, 3 x values to the left of or less than negative 1, and 3 x values to the right of or greater than negative 1. Which ones do we need? We are approaching negative 1 from the right, so we're going to use these guys. We don't need these ones over here. We plug in each of these for the x values in our function and get the y values that go with those x values. You can see that our y values go towards negative infinity. They are decreasing exponentially, so the limit as x approaches negative 1 from the right of our function is going to equal negative infinity. Confirm this with your graphing calculator. You can see that at x is equal to negative 1, our function coming in from the right is going towards negative infinity.
You try.
Okay, Okay, here we want to evaluate the limit first. So one-sided or otherwise, we take our c value, plug it in for x, and see if we get a number. Sine of pi is 0. Ln of 0, however, is undefined. This means that we're going to have a vertical asymptote at x is equal to pi. Now we need to figure out, as x approaches pi from the left, is our function going to go towards positive infinity or negative infinity? To do that, we create a table. Pick 3 x values to the left of, or less than pi, and 3 x values to the right of, or greater than pi. Which ones are we using? We're doing the limit as x approaches pi from the left, so we want these ones, not these ones. We take 3.1, plug it in for x to our function, get the y value that goes with that. Take 3.14, plug it in for x, get the y value that goes with that. Take 3.1415, plug it in for x, and get the y value that goes with that. Now, it may not be super obvious here, but these y values are actually decreasing exponentially. Because of that, we can say that the limit as x approaches pi from the left is going to equal negative infinity. We can confirm this with our graphic calculator. You can see somewhere around 3.14159.265 ... our pi value. Our function, as we approach from the left, is going to go toward negative infinity. Therefore, the limit as x approaches pi from the left of our function is equal to negative infinity. And you're done.